We should probably move to the next presentation. We're now going to, thank you so much. We're now going to a much smaller scale because it's going to be preparation of a filter to correct drop size distributions of Parsivel disdrometer based on the particle speed limitation. And it's Isabelle Costa presenting.
Good morning, and this presentation is about preparation of a filter to correct drop size distribution of Parsivel disdrometer based on the particle speed limitation. My presentation is separated into the following topics. The objective is to bring similar concentration of raindrops values from different types of disdrometers. To reach this goal, and in the framework of the Chuva experiment at Vale do Paraíba, the Oswald-Vogel disdrometer is used as reference, and a filter has been developed in order to eliminate inconstant data measured by the Parsivel work. The disdrometer is an instrument measuring which is the drop size distribution. This measures can be used to estimate the rain rate, radio reflective, and the drop concentrations for the 8th class of diameter. I use the rain data, the raw data of the disdrometer for this period. And this picture illustrates the disdrometer and the Parsivel disdrometer. The concentration of droplets is based on the flow equation, and depend the number of droplets, the air of the sensor, time, fall velocity, and diameter interval. In this picture, the figures use concentration of the two disdrometers, Parsivel here and DOS. Compare these figures, it's possible to observe the overestimation of the Parsivel disdrometer for the first class. For this reason, that a filter has been developed. Based on this observation, we have computed the average speed and the standard deviation for each class of diameter of the Parsivel disdrometer, representing this figure. The black line, the expected fall velocity, and blue line, the average velocity, and the red bars, standard deviation of this fall velocity. The expected fall velocity is that I use the equation for the determination. The results show that for class up to 7 millimeters, the results seem to be similar. For this, I use the expected fall velocity and standard deviation for preparation of the filter. For each diameter class has been calculated the Gaussian curve, use the expected fall velocity and the standard deviation. Based on the curve, for each class of diameter, it's possible to determine the minimum and the maximum of the fall velocity. In this picture is the Gaussian curve. Each color represents the class diameter. Okay, result. And this figure is the new concentration calculated to use the expected fall velocity and the standard deviation for the Parsivel disdrometer. And this in black solid is filter Parsivel, JAWS, and Parsivel without filter. It's possible to similar the the curve, but is supposed to observe the, in particular, underestimation of the Parsivel when you compare to JAWS. And okay, to solve this problem, the underestimation, the first class, I test the different values of the factor and from 1 to 2, range from 0.1, and the factor of 1.6, this the best of values factor to standard deviation when you compare these curves. Only this, there is still a weak difference around 1 millimeter. And this figure is we estimate the run rate and KDP, use the 2 disdrometer, JAWS, and filtered Parsivel, 1.6 is, you can observe the two distributions similar to be similar. The next step is develop the filter for all campaigns. Thank you.
So we have time for a couple of questions. Yes, please, Barbara.
I use the all no limitates the minimum. Yes.
Just one comment. What's the problem with that? The deep problem brain is not very lot of people. But the people have so these people are working very clear on the more lot of the high people more the idea is to test future the best the microcaya also has a specific filter, but we actually pay how to filter out. But we got the data and compare the data from the science and the disdrometer job correction using the software and this filter and job and this filter should be better than
Fala. Fine. I don't know. It is the wrong there. Mm,
See, that's great, but if you
why?
why do you have to hate it? But
Not sure.
my keypad is very, very easy.
Yeah.
Yeah, I think it's a number is too high.